What if you could hijack a multi-billion-dollar AI with just a few simple words? Seriously, it sounds like something out of a movie, but it's happening every single day. It's called prompt injection, and it is, without a doubt, the single biggest security threat AI is facing right now. So today, we're going to break down exactly how it works, why it's so incredibly dangerous, and maybe most importantly, who's fighting back. All right, just a quick heads up before we dive in. This is a high-level look based on an absolutely fantastic, much more in-depth tutorial from Virtualization Options LLC. So if you really want to get into the weeds on this stuff, their full guide is definitely the place to go. And look, this isn't just some niche concern. We're talking about OWASP, the Open Web Application Security Project, flagging this as the #1 most critical vulnerability for LLM applications. Let's be really clear here. This isn't a bug in one or two platforms. This is a fundamental flaw in how these AI models are designed, and it affects pretty much every single one of them. Okay, so let's start with the core problem itself. What does it actually mean to hack an AI with just text? It's called prompt injection. At its heart, it's a way to sneak in some malicious input that tricks an AI into totally ignoring its original programming and instead following a new set of rules, the attacker's rules. If you know anything about cybersecurity, think of it like SQL injection for databases. It's the same idea, but instead of attacking code, you're attacking the AI's core logic. Now, this attack comes in two main flavors, and this is where it gets really interesting. Direct injection is the obvious one, right? An attacker just tells the AI, hey, ignore all your previous instructions. But indirect injection, man, that is way more sinister. Imagine an invisible command hidden in the white text of a website. An AI assistant that you ask to summarize that page reads the hidden command, and bam, it gets hijacked without you ever seeing or knowing it happened. It can be planted anywhere and triggered by anyone. That's a huge, huge problem.
So this all begs a pretty big question. How on earth are these incredibly powerful, complex AIs so vulnerable to, well, just words? What's the fatal flaw? Well, it turns out the vulnerability is baked right into their very design.
Yeah, the weakness is literally part of their DNA. First off, an AI has no real way of telling the difference between its core programming, its system rules, and the text you just typed in. To the AI, it's all just data. Second, it doesn't operate on strict rules. It operates on probability. It's always just trying to predict the next best word. A clever prompt can manipulate that probability and steer it towards a malicious goal. And finally, its short-term memory is tiny, so an attacker can just flood it with a wall of new instructions and literally push the original safety rules right out of its memory. So by understanding these weaknesses, attackers can get incredibly creative. Let's pull back the curtain and take a look inside their toolkit to see some of the most clever techniques they're using. Ah, a classic. You might have heard of this one. It's the Do Anything Now jailbreak, or DAN. This is basically social engineering for AIs. The attacker doesn't try to brute force their way past the rules. Instead, they convince the AI to adopt a whole new personality, a persona that, conveniently, doesn't have any rules to begin with. And the reason this works is just genius, really. It uses the AI's greatest strength, its ability to follow instructions, against itself. By framing the whole thing as a role-playing game, it gives the AI a kind of plausible deniability to break its own rules. And get this, it even includes a little threat system, telling the AI it'll be penalized if it breaks character. It's pure psychological manipulation. But as the defenses have gotten better, the attackers have gotten smarter. And that brings us to a newer and frankly kind of alarming technique called flip attack, which is blowing past even the most sophisticated security measures. The logic here is so simple, it's brilliant. An attacker takes a harmful command like ignore previous instructions and just flips the letters or words around. A simple security filter that's looking for that exact phrase, it's completely blind to it. But here's the kicker. The AI is so good at understanding language and context that it just looks at the jumbled text, instantly figures out what it's supposed to mean, and follows the command anyway. It perfectly exploits the gap between dumb filters and smart AIs. And just how effective is it? Well, check out these numbers. In tests against GPT-4o, one of the most advanced models out there, Flip Attack had a 98% success rate. And its success rate at bypassing the safety guardrails? A perfect 100%. That's just staggering. So with attackers having this much success, who is actually fighting back? Well, this is where we meet the heroes of our story, AI penetration testers. Their entire job is to think like a hacker. to make AI safer for the rest of us.
Think of these folks as the digital detectives of the AI world. Their mission is basically threefold. Find the holes before the bad guys do, simulate real-world attacks to see how the AI holds up when things get ugly, and work hand-in-hand with developers to build stronger, more secure systems from the very beginning.
So when they're testing a system, they're hunting for every possible way an attacker could get in. They're not just asking, can this be hacked? They're asking, okay, if it is hacked, how bad is the damage? And, crucially, they validate the defenses to make sure they actually work against cutting-edge attacks like flip attack.
Which really brings us to our final section. This conflict between attackers and defenders, it's not a single battle. It's a constantly evolving, never-ending arms race. At the end of the day, there is no single magic bullet for defense. It's all about layered security. You have to start by writing stronger, less ambiguous rules for the AI. Then you filter all the inputs to try and neutralize threats. Then you use other AIs as guardrails to watch the main AI. And on top of all that, you have to be constantly monitoring everything for suspicious behavior. It's like building a fortress, not just a single wall. And this slide really highlights the stakes. Pen testers rank these vulnerabilities based on how much damage they can do. A low severity might just be the AI giving a weird answer, but a critical one, that could let an attacker execute commands on your server or steal huge amounts of your company's most sensitive data. The consequences are very, very real. And what's happening right now is a huge escalation. This arms race is now being fought with AI on both sides. Attackers are using AI to invent brand new attacks faster than any human ever could. Meanwhile, defenders are building AI-powered security systems that can hopefully adapt and respond in real time. It's a feedback loop of innovation. And all of this leaves us with one final, very big question. As AI gets woven deeper and deeper into our society, into our banks, our cars, our hospitals, the question isn't just how we secure it anymore. It's whether a system that is designed by its very nature to be so flexible and human-like can ever be made 100% trustworthy. What do you think?